5.1, solve inequalities using addition and subtraction. This will be the same as what we've been doing since chapter 2, solving equations, graphing equations, except this time we're using inequalities. If you have an inequality that is open, that means that it does not include the number, and that would be for if it's less than or greater than. If I have less than $5, that means I don't have 5. I have less than 5. That would be an open circle, and then a closed-in circle is going to be less than or equal to, greater than or equal to. If I said I had $5 or less, now that includes 5. It could be equal to 5 or it could be less than 5. Example 1, graph. Reading from the variable, I see right next to the x is a closed part that makes x less than 3. At 3, I would put an open circle. It doesn't include 3. It's less than 3. And then I would draw a line going in the less direction. Draw it on the number line and just darken it a little bit. That's an open circle and less than 3. X is less than 3. It doesn't include 3, but it starts the second you leave there at 2.99999 and less. We have that x is now next to the variable is the open part. X is greater than or equal to -1. I go to -1. It's greater than or equal to it, so it does include it. That means I'm going to color that in. It includes -1, and it is also greater than. It is equal to it, and it is greater than -1. Example 2. The highest temperature recorded in the United States was 134 degrees at Death Valley, California in 1913. Use only this fact to write and graph an inequality that describes the temperature in the United States. So it was the highest temperature at 134. It was 134. And that was the highest that it was. So what other temperatures would it be? Would it be 135? No, it is less than that. That is the high. So that means everything less than 134. You would say that the temperature is less than or equal to 134 degrees. The small part, the closed part, is next to t, so that makes t less than or equal to 134. Write an inequality for the graph that's represented. Here, we see they're telling us that it's at -6.5. It doesn't include -6.5, so we know that x is something to -6.5. X is, well, we see that this is our number line, and the numbers are getting bigger as you approach 0. The negative numbers are getting bigger, so x would be greater than -6.5. X is greater than. It's not included because it's not colored in, so x is greater than -6.5. Here we have that x is something to 4. Well, what's going on? X equals 4 because it's colored in, and it is less than. The numbers are getting smaller. X is less than or equal to 4. X is less than or equal to 4. We also have equations, inequalities to solve. The same idea as solving if we had an equal sign. What's being done to the variable? It's being subtracted by 5, and the opposite of subtracting 5 would be to add 5. Add 5. We have x is greater than -3.5 plus 5. Here's the decimal on 5. Those are unlike signs. We need to subtract them. So that is 5.0 minus 3.5. Borrowing. And we get 1.5. Is it a positive 1.5 or a negative 1.5? 5 was bigger, therefore it's positive 1.5. Example 5, Luggage weights. You are checking a bag at the airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weights W that you can add to your bag. I have luggage, and I already know that I have 16.8 pounds. It says it can weigh no more than 50 pounds. That means it needs to be less than or equal to 50. And solve that equation. Subtract 16.8, subtract 16, line up my decimals. And we get x is less than or equal to we get 33.2